we're going to be going through the Build an AI Security Guard for AWS project. Super cool project. It's relatively difficult, pretty spicy. Should take about 90 minutes. It's going to be free. The related projects are set up an AWS account and cloud security with AWS IAM. It's a good one to do prior to this, although certainly not required. Some of the key concepts are AWS Boto 3, that's the Python library we're going to be using here, Cursor, Amazon S3, and AWS MCP. So we're going to be building an automated S3 security scanner that detects AWS vulnerabilities and uses AI to automatically fix them. This could have prevented a breach that costed a company called Capital One over $150 million, so certainly very important. Cool, so 30-second summary. Enterprise security teams at companies like Netflix, Airbnb, and Stripe use tools like Amazon GuardDuty Security Hub and Prowler to automatically monitor thousands of AWS resources against security best practices. When they find issues, they fix them fast using automated remediation. In 2019, a misconfigured S3 bucket costed a company called Capital One $150 million. It exposed 100 million customer records. And in 2025, the Codefinger ransomware group encrypted S3 data in multiple companies. These breaches share a common thread, preventable S3 security misconfigurations that automated scanning could have caught. Most teams check AWS security manually through the console, read compliance reports, and hope for the best. Or they could automate it like we're going to do today. So professional security teams use AI-powered scanners. These are tools that analyze AWS resources instantly and catch issues before they become breaches. In this project, you'll build one, write a scanner, run it, and see vulnerabilities with the severity ratings. What you'll build in this project, you'll use Python with Boto 3 and Cursor with the AWS MCP to build an AI security guard that detects and automatically fixes AWS misconfigurations. Do I need an AWS account? For this project, you certainly do. You can follow the set up an AWS account for free project. And the free tier is more than enough for this project, so that's all good. It's not going to cost you anything there. Why AWS MCP for security? AWS MCP bridges Cursor's AI with your AWS account through Boto 3. Instead of manually writing fix commands, you tell Cursor fix all critical S3 buckets and it executes the Boto 3 API calls for you. Professional security teams use similar AI-assisted workflows to remediate faster. If you're new to AWS security, you don't need any prior experience for this project. This project teaches how to scan AWS resources and craft automated fixes using AI. So if you have done some stuff before, that's great. But if you haven't, that's totally fine too. Cool. How you'll build it. First, you'll write a security scanner that checks your S3 buckets for public access misconfigurations. Then you'll configure the AWS MCP and Cursor so you can fix issues through conversation. By the end of the project, you'll have a working scanner that detects S3 misconfigurations with severity ratings, an AI-powered fix workflow using Cursor and the AWS MCP to remediate issues automatically. Also, in the secret mission, we're using AI to automatically fix all security issues through natural language. Cool. Very good. So this is a diagram here of what this project is going to entail. So we've got a Python scanner script we're going to write. This is going to be called scanner.py. That uses the Boto 3 software development kit to interact with Amazon AWS S3 buckets. And we're going to be talking through the Cursor, which is the IDE you'll be using, chat with the AWS MCP as a bridge to the S3 buckets. So using API calls, we'll also be able to talk to that and fix and understand stuff. Cool. So what are we doing in this project? In this project, I'm going to build AWS security scanner script to detect potential issues with my S3 buckets. And configure the AWS MCP. This will help me learn how to learn best practices in monitoring and fixing S3 or AWS security issues. I'm interested in this because large teams have had, large companies have had big problems with S3 bucket security in the past, and I want to avoid this. Okay, what are we doing in this project? In this project, I'm going to build an AWS security scanner script to detect potential issues with my S3 buckets and configure the AWS MCP. This will help me learn the best practices in monitoring and fixing potential AWS security issues. I'm interested in this because large companies have had big problems with S3 bucket security in the past, and I want to be able to avoid this. Cool. We'll do this quiz at the end, but you're welcome to do it at the start. And this project walkthrough is going to be in the step-by-step guidance mode. There's definitely a low and a no touch here, like low guidance and on your own, which has less guidance going through the project, but you still ultimately get the same learnings if you walk through those. But we'll be going through the step-by-step guidance today. Cool. So step 1, setting up your security automation environment. Let's get your environment ready for AWS security scanning. We'll install Python, the AWS CLI, Vulnerabilities 3, and configure your AWS credentials, everything you need to scan and secure your cloud infrastructure. In this step, you're going to install Python, install the AWS CLI, set up AWS credentials, install Vulnerabilities 3 and UV, and create your project folder. Okay, in this step, I'm setting up my environment. This involves installing Python, or making sure it's installed, installing AWS CLI, setting up AWS credentials, installing Vulnerabilities 3 and UV, and creating my project folder. I need to do this so I can communicate to AWS, AWS S3 buckets. Cool. So install, this is the first part, installing Python 3.12. Why Python 3.12 or above? So Python's the language we're going to be using for this project. We'll need 3.12 or higher because it's what the packages we'll be using require, like Vulnerabilities 3 or the AWS SDK as well. And it's also got better performance than older versions. Cool, so we're just going to check what version we have installed. So I'll just run, it's a little bigger, and we can run the so if you're on Mac, you can run the Python 3 version, and on Windows you can run the just Python version. If you're on Mac, you can actually run this, but there's just a chance that, and if you're on an older version of Mac, or if you've never touched Python, because Mac OS comes with Python installed, that be an older version. Yeah, Python 3 might be your only option, but this could totally work too if you're on Mac. But we'll just check. So greater than 3.12, that's great. Cool, so I see a version number. Definitely you can follow through these steps if you don't have Python installed. So yeah, but we do, so we're going to head through here. Here's a step for updating as well. So now we're going to install the Amazon CLI. To do this, we will also open up the CMD tool here. Yep, so if we just run the AWS -- version command, we can see that I don't have the AWS CLI installed. That's all good. So I don't see a version number, so I'll come onto this command not found tab here. And I'm on Windows, so I'll click on this. So we're going to use this. We're going to download it using the MSI installer through the command line inside of PowerShell. But if you're on Mac, you can do the same thing with a different command in the Mac tab here. So we'll just go with that. Put it back into our command line. This installer comes up. Should just be a couple of minutes, maybe even less, depending on the other setup steps. Cool, so we'll just click through these here. Click next. Next again. Install. Cool, so it's quite quick, so that's good. Cool, almost done now. Once this is finished, we should be able to head back into our PowerShell and then run the same command. Maybe we probably need to restart PowerShell. And then once we've done that, we should be able to see we're operating on, or we have the AWS command line interface CLI tool installed. Almost done. Shouldn't be too much longer. And the reason we're installing the AWS CLI tool is because the MCP we're going to install later on, later in this step, is reliant on the command line interface tool that we're setting up, and we sort of have to configure this shortly. So yeah, going all good. All right, cool. So I'll just reopen PowerShell and then run the same command just to check that it worked. Cool, so we got a valid version of the CLI tool there, which is great. Okay, cool. So now we're going to configure the AWS credentials. What are AWS credentials and why do we need them? AWS credentials, so in our case this is an access key ID and a secret access key, authenticate your programmatic access to AWS. The security scanner we're building needs these to call the AWS API and access your S3 buckets and API application programming interface. Lets your code talk directly to AWS services instead of clicking buttons on the console. Your scanner sends requests to AWS and gets data back. Keep these credentials secure, never commit them to your version control. Very true. Okay, So what I'll do really quickly is I'll just pull this up. So we can see here when we run this, I get an error. You'll either get, or if you haven't set this up before, you get something like this, or you'll get something which is just saying you don't have any credentials. Either one, you'll need to go down this error path. But if you do, if you set something up, you'll get something like this, and we'll see that shortly once we finish setting it up. But if you haven't, like I haven't, then we'll go down this path. Cool. Okay, so let's configure your AWS credentials. So we'll need access keys here. If we don't have those, which sound like a big deal, we can go down this. We walk you through how. But if you already have access keys, you've already set those up, you can go down here and start the configuration immediately. But we will go through and set this up manually. So we'll head to the AWS console. I've just got this open here. What I might do is I might set it up there so we can see both. So we'll head to the AWS console. I've already logged in. We're going to search for IAM. We're going to hover over it. This can be a bit tricky with how AWS works and sizing here. Hover over it. I'm going to click on, hover over IAM. Click on IAM on top features, under top features, sorry. Click users in the left sidebar. Zoom out a little bit. And then click create user. So we're just going to go with my access key. Totally do whatever you want here. It's not super crucial. You don't need to click the provide user access to the AWS management console. Not necessary for this. Click next. We'll select attach policies directly, and then we'll put in administrator access. So we'll just click that, and then we'll click next. And then we'll click create user. Awesome. Okay, so you'll see user created successfully. So we'll go back to users. That's where we're at now, and click on the user you just created. So we'll call it my access key. So we'll click on that. Again, I'm just going to zoom out a little bit so we can see what's going on. Cool. So we're going to select security credentials here. And then we're going to scroll down to access keys. So we can see the create access key button here. And then we can select command line interface here. You can add a tag here, not really necessary. If you had a bunch of access keys, then that might be a really good option, but we're just going with one. So we only have one set up. So yeah, not a requirement here. So we're going to click create access key. Here's pretty important that we don't lose this access key, otherwise we'll have to do the steps we just did again to get it. So I'm going to copy it to my clipboard, and then I'm going to use that. We're going to use that shortly to configure the MCP, or to configure the CLI tool, which is then used to configure the MCP. But yeah, if you want to copy and paste this to a text file somewhere, or just put it in the safe place you'll be able to access. Again, definitely don't share it with anyone. So both of these values are actually really useful. The secret access key and the just the normal access key. They're both required for the configuration setup. So now we'll run back to the terminal here. and we'll run AWS configure, and we will enter our AWS access key. I've already set something up on this computer. This is an old key, which is, as we saw, invalid up here when I ran the command earlier. You can see security token is invalid. So I'm going to add a new one, which is so we can follow the prompts here. You'll be prompted to enter AWS access key. So this is your the access key, not the secret one. So that's this one here. So you can put that in, and then the AWS secret key, which I will put in here. This will be updated, or both of these will be revoked by the time anyone sees this, so that's fine, but certainly don't want to share this with anyone. You can see here that you're asked to choose a default region. There's a lot of different ways of getting this information, but yeah, your browser tag up here is probably the easiest one. That's easy to get to now. So copy that, put it in. I will do that, even though it's already selected correctly. And then you can choose here. You can do something like JSON, but none is kind of it's not necessary for what we're doing. So yeah, we'll just select that, press enter. Cool. Now we might need to restart to get this to work, but we'll see. Cool, there you go. So we've got a valid AWS credential set up. Very good. Okay, cool. Now we can minimize this. We can also minimize that. But what I will open up is Cursor, which is the IDE we'll be using to do this project. And this is where we're going to configure the MCP inside of. Cool. So I'll just open Cursor up. 1 second. Awesome. So we've got Cursor open here. We're going to click Open Project. We're going to go to my desktop. We're going to call this new file AWS Security Guard. We'll select the folder and click Open. Just Cursor prompting me to update. That's all good. Cool. So we're in this folder now. It's good. So what we're going to do now is we're going to set up a virtual environment, which involves creating a venv file, venv. But yeah, a virtual environment is like a separate workspace for Python. It keeps all of your project packages isolated from other projects so they don't interfere with each other. So you had a bunch of packages installed globally. Maybe that's pandas, matplotlib, and a few others that are general and used for a bunch of Python projects, and you wanted some specific stuff like maybe the AWS CLI or Boto 3 or others for this project. They wouldn't interfere with if you had a different version of maybe those packages elsewhere in a different project, or just conflicting parts of different packages. So it avoids that. It's definitely the best practice for running Python code. Sorry. So to set up a virtual environment, let's run a few commands. We'll have to open the terminal first. You can go into terminal, new terminal from the top menu, or you can do control and apostrophe. There you go. Cool. Okay, so we're going to run this command to create our Python virtual environment. This can take 10-20 seconds. That's all good. You'll see a virtual environment pop up here, then this will finish in a second. Our next steps are to activate the virtual environment. We do this by running a command here, and you'll see a little tag pop up. You saw it just finished there. You'll see a little tag pop up before the PowerShell tag on Windows. Look a little different on Mac. Cool. So we're going to install Boto 3 and UV. What is Boto 3? Boto 3 is the official AWS SDK, software development kit for Python. It provides Python functions to interact with every AWS service, so that's S3, EC2, IAM, and hundreds more. It's the foundation for any AWS automation in Python. So now that our vendor is set up, we can install Boto 3. So we're just going to run the pip install command here, and that'll install Boto 3. The good thing about this, like I said, is that it's really just installing into this like file setup. It's not global installation or going to be anywhere else. Cool. So Boto 3 is finished installing. That's very good. We can check now if we have UV. UV is a Python package manager. It's a very fast Python package manager. It's written in a compiled language called Rust. It's a lot quicker than others. So we can see here that it is installed. If it wasn't, you could go down these steps and install it. That's totally an option. But we have it installed, so we're just going to run down this path. Cool. So we're just going to double check our virtual environment is activated. We can see the VMs there. Good to go. Here's an explanation of what UV is. UV is a fast Python package manager that we'll use to run AWS MCP, the AWS MCP server. Cursor needs to connect to AWS through MCP. UV will handle installing and running the MCP server packages automatically. Great. Okay, so we'll just check here that it did install correctly. Oh, copied the wrong thing. So we can see here that we do get a version number, so that's great. We are good to go. Cool. So we'll just take a screenshot of it showing this this version for Boto 3. Just go into Syncing Tool. Yeah, Boto 3 is definitely the most common, well, really like similar to pandas or matplotlib for if you're trying to interact with Python and pull in data and whatnot. It's what you're going to use for interacting with AWS through Python. So yeah, it's really good idea to get familiar with using it for AWS. So it's great that we're running a project with this. I think this is super valuable. For some reason my snipping tool is crashing, so we'll use another screenshot tool. Cool. You can paste images in now into this, so that's super useful. I'll be using that. Cool. So how did you verify your environment is working? I verified the setup by running pip list pipe select string Boto 3. The output showed that Boto 3 was installed. I showed Boto 3 version 1.42.7, which confirmed that Boto 3 was installed. Great. Perfect, your environment is ready. Now let's build the scanner that will detect the security vulnerabilities in your AWS account. Cool, so we're going to build your AWS security scanner. Let's build a Python scanner that checks your AWS security, your AWS S3 buckets, for public access misconfigurations, the same vulnerability that caused the Capital One breach. You'll write code using Boto 3 to scan your AWS account and detect security issues before they become real breaches. So in this step, we're going to create the S3 security scanner, add public access checks, and run the scanner. In this step, I'm building a security scanner that checks for public access breaches in my account's S3 buckets. This will allow me to catch breaches before they become a problem. Cool, so now we're going to create the scanner. Let's create the scanner file in Python. In Cursor, right click the File Explorer, left hand side, select New File, and we'll call this scanner.py. What is the .py extension? Files ending in .py are Python source files. When you run python scanner.py, Python reads and executes the code inside the file line by line. We're going to give you a few Python code outlines. It's your job to fill them in by clicking the placeholder and replacing them with the correct values. So we're going to create the scanner skeleton here, and then add the try and accept block to that. Let's go and add that basic structure of the scanner to your scanner.py file. This first block has just one placeholder, so the service we're interested in. Obviously, there's more than one service that we can use with Boto 3. It covers all the services, as far as I'm aware, on Amazon, or on AWS, sorry. So we're going to enter S3 in here. That's what we're working on. That's what we're interested in. I said sort of the beauty of this is the fact that this is just one bit. This whole project is just one bit of understanding AWS security. It's not. It would be impossible to teach that even in one project. It has to be a long set of things. There's just so much. But we're going to start with S3. So that's what we're working on here. You can definitely expand, and we do actually expand. Cool. So I will chuck that into our scanner.py file. Once you've added the placeholder, copy the entire code block into your scanner.py file. Should look like this. Does good. What does this code do? You can read off here. So we're importing Boto 3, the package we installed, from Boto core exceptions import client error. So that will be raising an exception later on that we haven't pulled up. Once in our try and accept block, which we're going to do next, and that will allow us to effectively catch any sort of errors and let the user, whoever's using the script, know what's going on there. And here we're defining a function called scan S3 buckets. The function of this, we can see in the doc string here, is to scan all S3 buckets with public access misconfigurations. So we're saying the variable S3 is, we're looking at, again, this Boto 3 library client S3. So we're interested in S3 from AWS. We're creating a array called findings. We're printing something that's just letting the person using the script know what's happening. They're just going to print out, or it's just going to print out this text followed by a new line. Again, we're defining a bucket variable, listing buckets in S3. Printing, we're going to say found this many buckets, the length of the variable, index. like the array, sorry. So that's how many buckets we have to scan. New line, and this is where it's going to sort of pick up from here. We're going to add the try and accept in this for loop. So for bucket in buckets, we're going to give the bucket name that picked up with Boto3, and then we print here scan complete found X issues, and this is the index we create here at the start, and then we're going to return that at the end. Cool. I think that explains pretty much what this here on the left hand side explains. Oh, there's also this at the end, which is just effectively when this gets called, this program gets ran. Yeah. Cool. So now we're going to add the security check logic to this Python code. Now let's add the complete try except block that checks each bucket for public access issues and handles errors. Try/except lets your code attempt something and gracefully handle errors instead of crashing. So this code has, again, one placeholder, your config key, the key response key containing the configuration settings, hint AWS nest the actual configuration key in a key named public access block configuration. So again, this is what we're trying to detect for. So we'll put that there. That didn't copy. We'll press enter, and then we can put that in our scanner.py file. So what does this code do? I'll briefly run over this here, but I can also explain it when we add it to our scanner.py file. This try except block checks each bucket for security settings, or for security settings of each bucket. So block public ACLs. Block public policy, ignore public ACLs, restrict public buckets, handles errors gracefully. Critical severity means no public access block exists at all. Cool. Okay, so you can see we're going to be adding it here. Delete that comment and replace it with the complete code block above. You can see there that pasting it sort of de-indented the try. That's all good. The try and accept lines should be aligned 8 spaces or 2 tabs from the left edge. Python is very sensitive to indentation. If it's wrong, the code won't run. Very true. So what we'll do now, I'll just quickly run over, zoom out a little bit and explain what's going on here. So try and accept inside of a for loop. So we're looping over all of the buckets that we have available to us, and then we're trying this stuff, and then we're accepting this as a end result if we don't get what we want effectively. So yeah, if not in all these tags, we're going to append this stuff to findings. So that's the index we made, sorry, the array we made up here, and then print warning, bucket name, public access not fully blocked. And so that's what is going to get caught in the try. And then if there's an error, we're going to write that as E. So if E.response error code equals the thing we're trying to detect for, findings append, and we're going to say that's a critical error. So this is really what we're looking for here. We're trying to detect, has there actually been this misconfigured, so that this is effectively public information in an S3 bucket. So then, if that is the case, if we have detected this is, public access block configuration doesn't exist, we're going to say this is critical. We're going to print that out, and then again, because this is an accept, we've got a could not scan bucket. So that's another sort of outlier there. That could be a possibility, and then could not scan bucket name as well outside of the second accept. And then we'll continue to print this and return our findings array at the end. Cool. So this has a similar take here over what I just said. So this try/accept block checks each bucket for security issues and handles errors gracefully. The try block, this is where we check each bucket security settings. That's the if not all. there. So this is checking get public access block bucket name that fetches the public access block configuration for the specified bucket. Config public block extracts the actual configuration settings from the AWS response. So if not all, checks all 4 security settings at once. Finding.append adds a dictionary to the findings list with details about the security issue. Print, that's just a warning. The accept block captures the AWS API errors. This is like not stuff necessarily that could be an issue in for your S3 bucket. It could just be something configured incorrectly if you've got your token set up wrong or anything like that, or your access key, sorry. And then there's some other stuff in there as well. Cool. So you've got the else as well, any other AWS API errors, that's this guy. And then the second accept catches non-AWS errors, so network issues, unexpected issues, unexpected errors, sorry, so the scanner doesn't just crash. Why try and accept? Without error handling, the scanner would crash on the first problematic bucket and never check the rest, so the try and accept inside of the for loop lets us handle each bucket's errors individually for and continue scanning. And this for loop is just like looping over every bucket we have is what that's doing. Cool. So this is what it should look like in full, and it does. No errors, that's great. So I'll just zoom out a little bit and take a screenshot of this for the thing here. Cursor off. Cool. So I'll just paste that into the there you go. Cool. So how does your scanner work, and what did you build? So my scanner checks S3 buckets by first creating, that's not really how it checks them, by looping, using a for loop to loop over all available buckets on my AWS account. Then it checks all 4 test cases. You can just copy these in here. The try/accept blocks handle AWS and non-AWS errors. I learnt that we could say if I don't use a try and accept block, if I don't use a try and accept block, the scanner might run into a crash. Cool, so how does your scanner work and what did you build? My scanner checks S3 buckets by using a for loop to loop over all available buckets on my AWS account. Then it checks all 4 test cases. That's block public ACLs, block public policy, ignore public ACLs, and restrict public buckets. The try/accept blocks handle AWS and non-AWS errors. I learned that if I don't use a try and accept block, the scanner might run into a crash. Awesome. Excellent. Your scanner can now detect security issues. Next, we'll connect Cursor to AWS so you can fix those issues automatically through the chat. Nice. Let's zoom back in here, it's hard to read. Cool, so step 3, connect Cursor to AWS with MCP. Time to connect Cursor to your AWS account using the AWS MCP server. This connects Cursor to your AWS infrastructure, so you can scan resources, analyze results, and fix issues simply by chatting. Cool. So what is MCP and why do we need it? MCP, or Model Context Protocol, lets AI agents, assistants, and agents connect to external tools, like AWS in this case. The AWS MCP server bridges Cursor's AI with your AWS account. When you ask Cursor to fix all critical S3 buckets, MCP translates that into Boto3 API calls and executes them with your credentials. Without the MCP, Cursor could only read/write files, not actually interact with AWS. Great. So in this step, you're going to configure AWS MCP inside of Cursor, restart Cursor, and then verify the connection is working. What are we doing in this step? In this step, I'm connecting Cursor to AWS. This involves configuring the AWS MCP inside Cursor, restarting, and then verifying the connection. I need to do this so I can interact with the AWS MCP through Cursor chat. Cool. What are we doing in this step? In this step, I'm connecting Cursor to AWS. This involves configuring the AWS MCP inside Cursor, restarting and then verifying the connection. I need to do this so I can interact with the AWS MCP through Cursor chat. Awesome. So now we're going to add the AWS MCP configuration in Cursor. Cool. So in Cursor, we'll click the settings icon in the top right corner. And then it should pop us up with a mcp.json file here. So let me so we'll just click add custom MCP. Now we're going to put this in. This is your mcp.json that we'll add. So we're going to replace your region with the one we set earlier in the AWS configure menu. If you don't know what that is, if you've forgotten, then you can run AWS configure get region. We can do that. So that's what we set it as. So AP Southeast 2. So what we'll do is we'll just paste that in there, press enter, and then we will paste that inside of here. Cool, so what does the configuration do? This JSON tells Cursor how to start the AWS MCP server. So you're setting command as UV. This tells Cursor to use the UV package manager we installed or made sure was installed earlier on to run and manage the MCP server. Args are special arguments that specifies to install those arguments. So like AWS labs.aws API MCP server, something we're installing there. Environments or environment variables, env. We've got AWS region in there, which is what we've replaced, added with our specified region. This sets the AWS region the server should connect to. So when cursor starts, it reads this file and sets it up. The server connects to your AWS account using the credentials you configured, and this gives cursor the ability to execute AWS API calls on your behalf through chat. Cool, so this is set up. It might work without restarting, but MCP servers work on sort of a reboot, or at least in cursor they do. So definitely, I'd suggest restarting. Hopefully this goes green in a second. We can debug if it goes red. Can take a little bit of time, but there you go, goes green. So after restarting cursor, go to settings. That's where we already were, tools and MCP. Look for the AWS MCP server. So the indicator is green. That's great. We can see that 2 tools enabled. This is sort of misleading because it looks like only two tools, but these are like very they're tools which one just actually calls whatever the suggest AWS the correct suggest tool does. This one will go and actually fetch all of the tools from the MCP server, so they're just not listed here. Cool, so we're good to go, but if you're stuck here, there's some troubleshooting options, and then if you're still stuck after those, then you can go use the ask feature here, or you could go and go talk to the community. There's great people there, always someone that can help you out. Cool, so we'll upload a screenshot of the AWS MCP connected. So I'll just take a screenshot of this. Cool, so how did you connect cursor to AWS? I configured the connection by setting up cursor in the mcp.json file. I verified the MCP connection by checking my cursor MCP settings page. That confirmed that the AWS MCP was available and ready to use. How did you connect cursor to AWS? I configured the connection by setting up cursor in the mcp.json file. I verified the MCP connection by checking my cursor MCP settings page. This confirmed that the AWS MCP was available and ready to use. Cool. Step 4. Test your scanner with AI created issues. Now it's time to put everything together. You'll use cursor with AWS MCP to create a deliberately insecure test bucket, then run your Python scanner to detect the security issue. So really full loop here. So in this step, you're going to create a test bucket with a security issue using cursor and the AWS MCP, and then run your scanner.py to detect the security issue. So what are we doing in this step? In this step, I'm testing my scanner. This involves creating a faulty test bucket so that test bucket. I need to do this to detect a critical issue using my security scanner script, which is scanner.py. So what are we doing in this step? In this step, I'm setting up, I'm testing my scanner. This involves creating a faulty S3 test bucket. I need to do this to detect a critical issue using my security scanner script, scanner.py. Cool. So we're going to create a test bucket using Cursor plus the AWS MCP we just set up so we do that to create a deliberately insecure S3 bucket. This will give our security script an issue to find and fix. Open Cursor's chat. That's Command L on Mac or Control L on Windows, and I'm going to send this prompt to Cursor. So I'll just close the Cursor chat there. Sorry, the Cursor settings. Open up the Cursor chat, and then if you had something called 1, 2, 3, 4, 5, which I think I might, you can call this something else. Just any 5-digit number will do. This is just really a test, and you can send this off to Cursor here. So it's just adding to the Cursor chat, sending it off, and you'll see it do some thinking. It might initially struggle to create a bucket without these, because this is quite a it's common to set things up with this public access block enabled, obviously. So yeah, that's how we want it set up. Cool. So it says it's gone ahead and done that. So if there's any MCP calls that come up, you can just click allow or run, and that'll be all good. So wait for confirmation. We've got that. We can see the AWS calls from the MCP. So what actually just happened, the AWS MCP server comes with built-in tools that Cursor's AI can use. When you asked it to create a bucket, the server automatically picked the right tools, so suggest AWS commands. It figured out which AWS commands create an S3 bucket, and we've got call AWS executed a creation command to create the bucket. Your bucket was created without public access blocks. This means anyone on the internet could potentially access its contents if you uploaded files to it. That's the security vulnerability your scanner will detect. This is your first time using AI to control AWS through natural language. How cool! Cool. Just jump back to here. Here. Now let's run the scanner that we just made and see if it picks it up. So open a terminal, make sure your virtual environment is activated. You should see a venv little tag at the start. You can see that there. Cool. So if it's not activated, you can run the activation command or use the ask feature here. That's all good too. Cool. And if you don't know why this matters, you can use the ask prompt as well to figure that out. So we're going to run our scanner. We're on Windows. So in the command line, in the terminal, we're going to run this. So it's going to use Bota here, and it found one critical issue with the test demo, security demo bucket we just created, which is super cool, exactly what we want. And the other 3 buckets that I have just on my AWS account have been picked up, but no issues there. So if you get an error, you can go down this path, but we don't have an error, we're all good. So we're going to go down this one. So your scanner detected the security issue. Your output should look something like this. Cool, so we can see that worked. You'll see found X buckets to scan. This shows how many buckets exist in your account. That was that print we talked about earlier. We see a critical error here, no public access block configured, and then a scan complete, found one issue, or more if you have other insecure buckets. So we'll just pop back here really quickly. I'll close the cursor chat just so we can read this. But we can see this critical tag here. We can see that warning, bucket name, public access not fully blocked. Or no public access block configured, I should say. and then it has the bucket name and the severity level, which is critical there. Cool. So that's that print line there. So doing all good. So what do these mean? Critical, the bucket has no public access configured at all. And the warning, if you see this for other buckets, it could have partial protection. Some of the 4 security settings are enabled, but not all. Cool. So we're going to upload a screenshot of the scanner results. Cool. So we'll just paste this in here. How did you test your scanner, and what did it detect? I created the test bucket by using the AWS MCP through Cursor's AI chat panel. When I ran scanner.py, it detected so it's going to let me copy this. No, it's not. Okay, that's weird. No public access. Public access block configured. This shows that there is a critical security flaw in my S3 bucket. Cool, so how did you test your scanner and what did it detect? I created the test bucket by using the AWS MCP through Cursor's AI chat panel. When I ran the scanner.py, it detected a critical issue there where no public access block configured was the case. And this shows that there is critical security flaw. There is a critical security flaw in my Amazon S3 bucket. Cool. Alright, so we're done with that. We're going to move on to the secret mission now. This is going to be automatically fixing the issues like this or plenty of others with S3 buckets, anything else, using AI or through the MCP. We just used to create an issue. Yeah, we'll go and resolve that. So automatically fixing issues with AI. So far you've built a scanner that detects security issues, but detection alone isn't enough. Professional security teams need to actually fix what they find. Very true. In the secret mission, you'll close a loop. So really before it was like a 3/4 circle, this is a complete closed loop. I'm going to use Cursor with the AWS MCP to automatically remediate the critical findings in your S3 buckets, then verify the fixes all worked, all through natural language using the Cursor chat without touching the AWS console. Cool, so this is the sort of outline of what we're achieving here. We've got our S3 scanner, which detected issues here, and we're going to use Cursor plus the AWS MCP to actually go and fix that and remove this detected issue there. So in the secret mission, get ready to use Cursor and the AWS MCP to fix S3 security issues through natural language and verify the fixes work by running the scanner again. So I'm using AI to automatically fix the security issues I detected. This lets me improve the security of my faulty S3 bucket. Professional tools do this because it is one thing to detect an error, but fixing it is just as important. Yeah, and then after that we're going to run the, after we think we fix it, we're going to run the scanner.py script again to check it worked. Cool, so we're going to do this part now, so fix security issues using Cursor plus the AWS MCP. Now let's use AI to fix security issues automatically. This is where Cursor plus AWS MCP shines. You can fix the AWS security issues through natural language. How good. So we're going to open Cursor's chat panel again. Use Command L on Mac or Control L on Windows, or you can just click in the top right. Cool, so we're going to send this prompt off. So Cursor ideally will use the AWS MCP to check your buckets, generate the AWS CLI commands to fix them, and ask for your permission to run commands. It might not ask that permission to me. There you go, it's doing it there. Asking for permission, and then execute the fixes. So what's actually happening behind the scenes? Cursor is using the AWS MCP server you configured to call suggest AWS commands to find the AWS CLI commands we need. Then calling the command call AWS to execute the commands like AWS S3 API put public access block, so adding that. And then, so there's no manual clicking in the AWS console required at all. So we can see that here, it's a critical finding. There's no public access block configured. So it's going to call that. Cool. So approve commands when they come through. Wait for Cursor to complete. Verify the fixes worked. There's just a note here. It has tendency to go and actually run the script for you and check. But if it does, that's great. If it doesn't, like it hasn't in our case, it's just said you could run this. That's ideal too. So what we'll do now is we'll run this. 4 buckets to scan, and scan complete. No issues found. So what we've done is we've gone through creating a fake or a real bucket, but just with like a issue we've implemented on purpose, and then gone and scanned that with our scanner.py script, found the issue, and then gone back to the Cursor chat, and then fixed the issue in AWS, and then ran the scanner again, and we've been able to see that with the MCP that we ran using the Cursor chat, we've been able to fix the AWS public access block being missing issue. We've got no issues now. So no critical findings. It's good. Still seeing critical findings. You can go talk to the community. There's also a few troubleshooting tips there. I'll use the ask panel here to ask questions about this project. But good, we get 0 issues. That's great. Should see found X buckets to scan, same number as before. Scan complete, found 0 issues. This security demo bucket is now secured. Great. So no critical warnings, no just warning messages at all. All buckets passed and are properly protected. So this is the power of AI assisted cloud security alongside the sort of the Vulnerabilities 3 library here, which really is an amazing way to really the way to interact with AWS through Python, much like Pandas is the go-to library, or matplotlib for that sort of data processing. Vulnerabilities 3 is the same for this. Super easy, super intuitive to go through and design something that your own scanning script. Like I said earlier, you can do instead of S3, you could do IAM. That's really not very tricky. You could run this exact setup like this, and then you'd have to go and configure this to have a try and accept relevant to something that configure get, and then instead of block public ACLs, it would be something relevant to IAM. So it's certainly very plausible to expand on this, and I definitely recommend doing that. So we detected security issues with Python automation, fixed them using natural language with Cursor, and then we did that all without touching the AWS console. I'll just run this again so I can get a better screenshot of the zoomed in view. Awesome. So how did you fix the security issues? I fixed the issues by prompting the Cursor AI chat to look into the issues I identified using my scanner.py script after I created a purposely faulty S3 bucket. The security problems detected were, I think that was public access block non-configured. So Cursor helped me by using API calls to add the public access block to my faulty S3 bucket. So how did you fix the security issues? I fixed the issues by prompting the Cursor AI chat to look into the issues I identified using my scanner.py script after I created a purposely faulty S3 bucket. The security problems detected were public access block not configured. Cursor helped me using API calls to add the public access block to my faulty S3 bucket. Cool. Awesome. So that's pretty much the end now. I'm just going to clean up and do a quiz and then a couple more validations. So clean up your resources before you go. Nice work completing the project. Let's clean up the resources we created. So the resources to clean up, we can deactivate your Python environment, virtual environment. We can remove the AWS test resources, optional, and delete the project folder, optional. So deactivate the virtual environment. You can either type exit to close the terminal and deactivate, or type deactivate. There, so we can see now there's no venv tag before our text. Or you can type exit, which also does the same thing, but just closes the terminal. So the AWS resources, if you want to keep the bucket, you can totally do that. If you want to delete it, you can do that as well. Or just keep it. Yeah, and if you ever want to run this again, you can just, like the inside the virtual environment, you just need to come back to where this is being ran. Make sure you're in the virtual environment with the scripts activate, and then run the script with Python scanner.py. And if you want to, you can add a git ignore here to protect your AWS credentials. That's only if you're adding this to Git. We haven't, so it's not an issue at all. But if you want to, you can do that. And if you want to delete your project files, the only one we've created today is the scanner.py inside of the AWS security guard folder here. So what about AWS MCP? The AWS MCP server is in Cursor and it's still configured. You can keep it, remove it, go to Cursor settings, tools and MCP, remove AWS server if you want to. But if you don't, that's completely fine as well. That's just up here. You can go and click delete there. So what were the key tools and concepts you learned in this project? The key tools I used were, say Cursor, say MCP, say AWS, and Python. Key concepts I learned include you'd say AWS S3 security, specifically public access blocks, you could say try and accept blocks. And try and accept blocks. The most important skill was, I would say, learning how to create a system which enables the identification of S3 buckets that could be vulnerable for a breach. Cool, so what were the key tools and concepts you learned in this project? Tools I used were Cursor, MCP, AWS, Python, and Python. Key concepts I learned include AWS S3 security, public access blocks, and try and accept blocks. The most important skill was learning how to create a system which enabled the identification of S3 buckets that could be vulnerable for a breach. How long did this project take to complete? Took approximately 1 hour and say 1.25 hours roughly. The most challenging part was configuring my AWS credentials. It was most rewarding to fix the AWS 3 bucket security issue. So how long did this project take you to complete? This project took me approximately 1.25 hours. The most challenging part was configuring my AWS credentials. It was most rewarding to fix the AWS S3 bucket security issue. Why did you do this project today? Did this project meet your goals? I did this project today because I wanted to learn how to manage AWS security using AI. This met my goals by highlighting the use case of both Boto 3 for manual scripting of AWS checks and the AWS MCP for more on the go fixes and queries. Next, I plan to update this script to focus on IAM security vulnerabilities. So why did you do this project today? Did this project meet your goals? I did this project because I wanted to learn how to manage AWS security using AI. This project met my goals by highlighting the use case of both Boto 3 for manual scripting of AWS checks and the AWS MCP for more on-the-go fixes and queries. Next, I plan to update the script to focus on IAM security vulnerabilities. On finding IAM security vulnerabilities. Cool, that's a wrap. You did it. You built an AI-powered AWS security system using Python plus Cursor plus the AWS MCP. This is what the your sort of architecture diagram looks like. And what you've learnt is AWS S3 security and public access configurations, Python automation with Boto 3, using Cursor with AWS MCP to control AWS through chat, building security automation workflows, security scanning and risk management. Cool, so ready to quiz yourself? Do this. So what is the primary role of Boto 3 in this project? To provide command line interface for AWS services, to install Python packages efficiently, to manage Python virtual environments, to serve as the official AWS SDK for Python, enabling interaction with AWS services. I think that one. What is the main purpose of creating a Python virtual environment in this project? To speed up Python execution, to connect Cursor directly to AWS, to manage AWS credentials, or to isolate project dependencies from other Python projects. I think it's that one. How does Cursor, with the help of the AWS MCP, interact with your AWS account to perform actions like creating an S3 bucket? By manually prompting the user to type AWS CLI commands, by embedding a full AWS CLI client within the Cursor IDE, by translating natural language commands into Boto API calls via the AWS MCP server, by directly executing Python scripts within the AWS console. I think it would be by translating natural language commands into Boto 3 API calls via the AWS MCP server. Why does the project specifically require Python version 3.12 or higher? It is only version compatible with Cursor IDE, simplifies the installation of the AWS CLI, it offers modern security features, compatibility, latest version of Boto 3, and improved performance. Older Python versions cannot create virtual environments. B. Which AWS service is Python scanner built in this project, primarily designed to audit for public access misconfigurations? AWS EC2 instances, AWS Lambda functions, AWS S3 buckets, or AWS IAM roles. So we're working in S3 buckets. What is the significance of running the AWS STS get call identity command during the setup phase? It installs the AWS command line interface. It verifies that AWS credentials are correctly set up and configured. It creates an IAM user with administrative access. It lists all three S3 buckets in your AWS account. All S3 buckets in your AWS account. It verifies the AWS credentials are working correctly and are configured correctly. Cool. Awesome. So if it says task still to complete, then you can go use this to go and select stuff that you haven't done. But we get this, so we're going to go ahead and look at the documentation. Awesome. So we can see our title here, build an AI security guard for AWS. We can see an image here, which is the scan we did not at the end, but beforehand, but we still had the issue. We can see introducing today's project, key tools and concepts, other images throughout the project, the S3 scanner code itself, successful configuration there, testing the scanner, fixing the scanner with AI, which is cool. You can change the theme to light, dark, or fun, like we had it on there. You can also go and share content. So yeah, I'll go copy this into the Discord, or you can just click the Nextwork Community Discord link here, and I'll share it on LinkedIn. You can also download it as well. Just open this up in my browser over here. But yeah, really, really cool project. I think it provides heaps of value and looks amazing on a portfolio. So yeah, definitely would recommend doing this project and checking on LinkedIn. So we can see here the template here you get. So yeah, super cool. And you can copy the live URL there. You can edit these things here as well. You can edit the images as well inside of this documentation. But yeah, super stoked. I think that's a wrap. But yeah, super cool project. Yeah, so good to be able to sort of combine that Boto 3 and AWS MCP stuff, so that they work almost in parallel. They really complement each other in the workflow. So scripting is very automated. You're going to run this 100 times, where a call you do to the AWS MCP might be just once, like I'll fix this one bug. So it work really well to complement each other. All right. I'm going to end this here, but I hope you enjoyed if you followed through. Yeah, thanks so much for watching.